Hi, it's come to my attention that some of you are continuing to do the lessons in the book, which pleases me greatly, even though they will not appear on this year's AP exam. If you want to say you've done a complete AP course, finishing up the work in the book is an excellent idea. I've had questions on chapter 23, particularly on section 23.5, numbers 23 and 25. I love these kind of things, so I'm glad to send out this video. First of all, on number 23, it doesn't give you the voltage, but it does tell you 3 amps go down this branch and 2 amps go down this branch, and 10 ohms is over there. Well, if you remember what I've told you, voltage doesn't split. So the voltage is the same in both of these. So the voltage is the same in both of those branches, okay? The amps will split, and so 3 amps, 2 amps, this over here would be 5 amps because it has split into 3 here and 2 there. Now, resistors. This has only one resistor, so we know the voltage is going to be amps times resistance. So 3R is what it is going through this branch. Now the voltage going through this branch is going to be equal, so we can do, now why did I say R plus 10? Well, if they are one after the other, that's called resistors in series. Resistors, when they're in series, all you do is add them up to get the equivalent resistor. So what you do is you put them together as if they're one resistor to see what the equivalent resistance is. And since we know the voltage goes the same in each one, we can set up an equation like this and get 3R equals 2R plus 20. So that resistor right there, R, and since they're both the same, those are 20. Now what's the voltage? Well, V equals IR, so 3 times 20, the voltage is 60 volts. So that's how you would get those two answers. Now 25 goes like this. First of all, 10 volts is going through every part of this. Voltage, remember I said, is like a stream. It's all the same elevation. However, once it goes down a waterfall, then you've lost some of that voltage. So you have a little bit less voltage going through each of these than you have over here. Okay? So you have 10 volts, then it goes down a waterfall, and you have a lesser amount of volts going through these. Well, how do we find out how many volts? Well, we use V equals IR, and first we find the equivalent resistance. And once we have the resistance and we have the volts, we can find out how many amps there are over here. Okay? When the system is all put together, we can find out how many amps are going through before they split up. So let's go ahead and get our equivalent resistance. First, get all your parallel resistors and get what they are. So then all you have is this in series and then your equivalent resistance in series. So let's get the parallel. So you would do 1 over 5 plus 1 over 5 plus 1 over 5 equals 1 over my equivalent resistance. So 3 over 5 equals 1 over my equivalent resistance. So if we cross multiply, 3 times my equivalent resistance equals 5. So my equivalent resistance equals 5/3 or 1.67 ohms. Okay? So that is these three put together. And now that and that are in series. So 5 plus 1.67, in other words, 6.67 ohms is my entire equivalent resistance for that entire circuit. So we can use this to find our amps. So we can do 10 divided by 6.67, and that gives us 1.5. So 1.5 amps is what is going out here. So to find out how many volts we've lost, we now do 1.5 times 5 because V equals IR. So times 5, 7.5 volts, that's the voltage drop. 7.5 volts is what that waterfall has made lose. So if 7.5 volts have left, how many volts do we have left to go through these? Well, 10 minus 7.5, we now have 2.5 volts that are going, now the elevation is down here, but it stays the same going through all of these. So we would just say 2.5 equals 5I. So 2.5 divided by 5, we would have 0.5 amps going through each of these. Okay? So this has split off evenly. Sometimes they don't. That's why you have to check. But since these resistors are all the same, it shows that it has split this, the amps. See, there's 1.5 amps, and 0.5 is here, 0.5 is here, 0.5 is here. See, they add up to 1.5. So Kirchhoff's laws are all not violated. And what happens is when this voltage goes back up here and goes back to the battery, it'll bump it back up to its 10 volts. So that's how you find all of your things. Remember, your voltage doesn't change unless it goes over a resistor. Then you find out how much it's changed by doing V equals IR and subtracting that from the voltage going in, and get your voltage that's coming out on the other side. And then you just do V equals IR for each of these individually to find out how many amps is in each one. So I hope that helps. You really don't have to do all of them. If you think, maybe try another one and see if you've got it. But that's the basics on resistors and circuits. And that's as far as it goes on the AP Physics one.